Now let's look at a few properties of real numbers as we talk about 3.3 from the Redwoods pre-algebra book. Whether or not you have the textbook with you, these properties are general in all of mathematics. And we're looking at the commutative property of multiplication and the associative property of multiplication. So the commutative property, very similar to what you've learned about the commutative property of addition. When two things are multiplying, you can multiply them in any order. So 5 times 4 is the same as 4 times 5. That is, if you move the numbers around, you will get the same value at the end of the day. So keep that in mind. It's going to help with solving math problems and just doing very well overall. So that's number one, is to keep that in mind with this property. The second property is the associative property of multiplication. So the commutative property of multiplication, and now we have the associative property of multiplication. So the associative property of multiplication. With the associative property, you would notice that it involves working with a set of numbers in a parenthesis. So let's say x times y times z is equal to x times y times z. So the grouping for the numbers, notice in the first case, the x and y are multiplying together first, and then you multiply that by the z. And in the second case, the x is by itself and the y and the z are multiplying side by side. So that's very important with the associative property of multiplication. So we have the commutative property of multiplication, the associative property of multiplication. In this section, there are about 44 problems, and you'll be doing number 1 to 43 odd. And most of these problems would be using either the distributive property, the associative property, the commutative property, and understanding of those properties to work out those problems. But keep in mind that a lot of the practice problems are focused on multiplying out things, or and that's something we're going to look at. We're going to look at the distributive property before we wrap up today. So let's look at a few examples from the few examples where you're using things like the associative property. So, for example, we have a situation where you have negative 5 into 8y, right? So the 8 times y are multiplying together in a sense, right? But this is an expression. 8 times y just stays 8 times y. And you multiply that by negative 5. In this case, we have negative 5 and then times 8y. That would become negative 40y. So that's the answer to this problem. We're multiplying this 5 and that 8, essentially, the negative 5 and 8. That's negative 40, and then the y just stays the same. So basically, you can regroup this if you want. If you want to rearrange things, you could take that negative 5 and the 8 together, and then the y by itself. So that's negative 40y. That is using the associative property of multiplication. So what we did was we put the negative 5 and the 8 together. They multiplied together first before they interacted with the y, and that's completely fine. Let's look at another example. 7 times negative 8x. So in this case, we have 7 times negative 8, right? These two will multiply together times x. So you have negative 56x. That is completely fine. That is good. You can regroup numbers that are multiplying and then simplify. So that's another example for you to keep in mind. Here's another example. Negative 2x times negative 10. Now, this one uses the commutative property as well in a sense, because we could take this and put it in front here. We could say negative 10 and then negative 2x, right? And then these two can come together. Negative 10 and negative 2 can multiply together, and then they'll interact with the x. This becomes 20x. So remember, we move this over using the commutative property of multiplication, and then we multiply. We can allow for association to happen between the negative 10 and negative 2. We multiply these two together and we get 20. A negative times a negative is a positive. That's important to remember with the integer arithmetic. That is very important. Integer arithmetic. A negative times a negative is a positive. A negative times a positive is a negative. So that's how we get 20x here. So let's look at another example. If we have negative 4x times negative 3y times negative 5z. Keep in mind that in this situation, you have x, you have y, you have z. We could technically keep those at the end, x, y, and z, and we can focus the numbers in here, -4, -3, and -5. -4 times -3 is actually 12, positive 12, times -5, which we'll come to in a second, and then x, y, z. -5 times 12 is -60, so -60 x, y, z. So the answer to this problem right here, or the solution, is -60 x, y, z. But notice that the letters could be brought to the end. Okay, they could be over here by themselves, and then the numbers can work together. So that's how we get our answer for this particular problem. We're going to introduce another concept. This concept is called the distributive property. The distributive property. The idea of the distributive property is that if you have a letter or a number or anything outside of parentheses, and then you have certain interactions within the parentheses, like a plus or a minus, so y plus z in this case, you can distribute that thing on the outside so that it multiplies with everything on the inside. So you have x times y plus x times z. Think of it like the letter or the number on the outside is essentially shaking the hands, like that, shaking hands one by one, right? So imagine if you had a into b plus c plus d plus e. If you were to distribute this a, it would actually become ab plus ac plus ad plus ae. That's how it would work out. So it's important that we remember that the distributive property is saying whatever is on the outside will touch on everything on the inside. That's how the distributive property works. We can do it, use numbers with the distributive property. So if you have a situation like this, 4 into 5 plus 9, you can technically add these two together and then multiply by 4. Or you can say 4 times 5 plus 4 times 9 and then add those together. So 4 times 5 is 20. 4 times 9 is 36. You add those together, you get 56. So that is one way that you can go about doing the problem. So you could do 4 times 5 and then plus 4 times 9. Or you could have added these two together. So you would have gotten 14 times 4, which is 56. So something to keep in mind with the distributive property. Your book also speaks about situations where where you have a negative on the outside of a distributive property, and the same principle will happen. Just remember the general principle. When we have a principle that says this is a b plus ac, then if it's negative inside, it would just be ab minus ac. If it's a negative a on the outside, then that would be negative ab minus ac, right? Because this negative is going to change when it meets the positive, it's going to make it negative there. So notice the principle is the same. The thing on the outside will multiply the things inside. The thing on the outside will multiply the things inside. The thing on the outside will multiply the things inside. That is how it goes, okay? The number or letter on the outside would distribute in. So let's say we had -6 into 5x plus 9y. This -6 will distribute with that. So that becomes -30x, and this -6 would distribute with that, and that becomes -54y. So because of the negative and the positive meeting, it will become a negative there. So that's an example of the distributive property. You'll have a few more examples of the distributive property. I'm going to put the video we've used in our algebra course as well as an extra resource for you here if you want to use that. Let me know if you have any questions on the distributive property or any of the other concepts within this section. Thank you and have a wonderful day.